Due to madam is not there. That's why. Yeah, once again, good morning to everyone, and back here with the IoT class. In our last class, we are discussing on how the IoT things means which will be taken as in a cloud. XaaS. So everything as an service. How cloud will give everything as an a service, and how the cloud computing will be there. Based on that, we are discussing, and we have discussed what is the need of the cloud computing and how the cloud computing will give the different services and how the cloud will be deployed. On that we are discussing, continuing with that particular thing. Just 1 minute. Yeah. Now back here with a lesson. In the last class, we are discussing on this particular topic. Yeah, that is broad network access, which we are discussed, and resource pooling on the services of access, which we are discussed, starting with this particular thing, how a cloud architecture means cloud will look like, and what are the things cloud will do, computation, storage, and data processing, where the application access and end users will be there, and developers, they will be means access it through the APIs and distribution services, whatever is there to set the services and all. So that we had discussed, and we have gone with cloud computing. What is a cloud computing actually? So on demand network is should give and configurable computing resources also it will give, and it will manage, means minimal management efforts, and service provider interaction will be there. So next we have discussed that the cloud computing however does not change the fundamental software engineering. It will follows that, and data processing capacities, compute storage, all these things it will show you. And the fourth component that is very much important, that is a distribution services also, it will be taken by the cloud. And according to the NIST, the characteristics of a cloud computing we are discussing, that is on-demand self-service. That is, whenever a need is there, as we have discussed today, consumer can unilaterally provision the computing capabilities such as server time and network storage as needed or automatically without requiring human interaction with each service provider. Whenever a device is connected to a cloud directly, if you written a code already stating like that, when the value is so and so, this particular value should be transferred to the cloud. If the code is like that, then at that particular time the request will be sent to the cloud via the API token, and once according to your user space and all, it will take that particular data, and a server time and storage will be given to you, and the data will be stored. Either you are storing a data intervally from a device every 15 minutes, like that you are storing, or event based data you are storing, or continuous data you are storing. It's left to you on your problem what you are going to do. And broad network access, that is capabilities are available over the network, and accessed through the standard mechanisms that promote use by heterogeneous thing or thick client platforms. That is, either in that particular side broad network access, what we will do means I will use my mobile smartphones to switch on the bulb, assume that so whenever a notification will comes to me like that, from last 1 hour your geyser is on, or your um, refrigerator or bulb is on, assume like that, or fan is on, a notification will come to my app, How a notification will come to my app means a cloud will be there as an means smart home, a cloud access will be there, and assume that the PAR sensor and the LDR sensor, light detected sensor, which we have used, and lot of light is there, daylight is there, and no one has no motion is detected last 15 minutes. Assume we'll write a code based on that. So the values whatever is there, it will goes to the cloud, and once the cloud values means the one, if no one has gone within 15 minutes, I will send some value one, or some value I will send, and LDR lot of light value will be there. Assume I'll keep a threshold of some 250 or 300 like that. If it is like that, lot of light is there. So then there I will, if that's the value, both values are there in a cloud. Assume now the data is here in a cloud. So in a cloud, what I will do, if this is the condition, automatically a notification should be given to the mobile app. Means the service enablement have to do within a cloud only. Am I right? So that a broad network access from there, again it will comes to the mobile app, notification will be given that from last 15 minutes your fan is on, and no person is there and light is there, something like that it will give. So now again assume that the user will go there to the app and see, yes, the fan or a bulb is on here, so you will press off buttons. Pressing a off button, the signal will goes to the cloud again back, and from cloud again taking that data, means from mobile data, taking that into the consideration, it has to direct the actuator, means the relay switch which you have stored or connected to your device, that should be activated, and then off or on should be done. Means a signal should be sent to your relay switch based on, sorry, light number or a relay number. So these are the major things which will be done in a cloud. I think now you got idea that what a cloud has to do. Resource pooling, no, that is another one important thing, that is the providers computing the resources are pulled to serve the multiple consumers using a multi-tenant model with different physical and virtual resources. So dynamically assigned or reassigned according to the consumer demand. So what is this resource pooling? Particularly, I want to use some particular resource in a cloud, assume. So if I want to use that particular resource, how I can use on demand, I can use, or virtually assume that n number of multi people will be keep on using. I am not only a person in a ThinkSpeak, whoever I am using that particular space, assume that, or a particular time of that particular server, or some activities in that particular server, maybe MATLAB analytics I am using with the online things. So taking all those things into the consideration, I am not only a single person. Assume at the same moment, at the same time, how many persons are using a ThinkSpeak cloud, or how many devices are in that time they are working. So it depends. Now virtually sharing of that resources dynamically and reassigning, means once if some device will leave that particular resource, means that should be reallocated to other device. So it will be done without any human interaction. That is very much important here. There is a sense of location independence in that the customer relay has no control or knowledge over the exact location of provided resources. But it's very clear that from where this location is giving, and from which particular server of the ThinkSpeak, or in which locality the server is there, and which server, either they are giving me the space and all, I never mind that. What is the thing? Very simple. My device, whatever it's sensing the data should go to cloud, where I have created my username, everything and all, and that data again should be transferred to the mobile, and from mobile, whatever the customer will take a decision based on that, my actuator should run. This is the only concentration as a developer I am having, that uh, I never mind that where actually in a cloud the data will store, and in which location it will store and all. So that is another one important thing in a cloud. And rapid elasticity means, assume that suddenly I want to store a more data. Capabilities can be elastically provisioned and released in some cases automatically to scale rapidly outward and inward, commensurate with demand. Assume that, for example, for me, 10 GB is allocated, and my devices never use a 10 GB from last 2 3 months. I am using only 2 GB. Then what actually they will do means they will minimize the space, and automatically the space will be taken by other things. Why? Because last 3 months, like that, we have not used that particular. Assume that my data is very large and suddenly I want to use, then automatically the virtual space will be created to me, and it will be given on demand in that particular sense. So here, what do you mean by the rapid elasticity? Means rapidly it can change the size of a memory, means it can shrink or it can enlarge that particular capacity based on your sensors or requirement. Assume, for example, I have created one particular means project in a things pick, and 4 sensors I have used. Maximum, I think we can use 10 sensors for a free users. Assume that I have used only 4, but you can ask me, sir, 10 users space will be there. That will always static? No, no, it will be not always static. Assume that then I want to add up another 3 4 resources. Yeah, you can add up. Then your the space will be reallocated to you, and it will be enlarged. Like that it will be do. Then measured service. So cloud systems measuring is very much important. Whatever things you are using in a cloud and all, for costing purpose, the measuring and how much data you have used and how much resources you have used in a cloud. So each and every, the bandwidth, processing, storage, and the user activities, everything, and controlled, monitored, reporting, transparency in how much you have used and all, so that utilized resources will be metered, and based on that the charges will be applicable. Now coming to the next thing, that is, once such infrastructures are available, however it is sorry, it is easier to deploy applications in a software. For M2M and IoT, these infrastructures provide the following. Especially, we are in the subject M2M and IoT. For my IoT projects, what actual infrastructures I need from a cloud? Storage of the massive amounts of data that sensors, tags, and other things will produce. Yeah. Why? Because assume that in a real time I will use the n number of sensors, and in the n number of sensors, continuous data. For me, assume that the data should be continuous. I want a continuous data, so that to store that continuous data, my cloud should have a capacity of a storage, computational capacity in order to analyze the data rapidly and cheaply. This is another one. Computational capacity should also be there. What actually to mean like that, a continuous flow of data is going there, and assume that whenever the threshold is there, something like that, a notification should be given to the app, or the user who is using a smartphone. So for this, I need a space for a computation also in a cloud. So the computational things should be done automatically when these particular values has been changed in the entities. Now over time, cloud infrastructure will allow enterprises and developers to share a data sheets, allowing for rapid creation of information value chains. So finally, what's the thing like that? Whatever a data I am stored, it should be generated for an enterprises or whoever may will take that. Is share data sets should be produced from that. Otherwise, we can't analyze and we can't predict. Means the process on that data or analysis cannot be done whenever a data sets will not be created. So when a data set should be created, for example, air pollution project, all 6 parameters continuously, assume that every 5 minutes are continuously left to you. So every 10 minutes it will read the values. Assume, for a sake I will tell you, and every 10 minutes the value whatever it's read will be recorded there. Now imagine per day every 10 minutes means 24 hours will be there. So every 10 minutes in that, the value will be taken into the consideration. So how many times it will take per day, and assume that per year, or sorry, per week how much it will take, or next per month how much it will data it will be generated, and six values or six parameters will be there. So that six values will be there. Now every 10 minutes is taking data, means that much of huge storing of data it will be there, and for analysis purpose, means enterprise, these data sets will be taken, for example, download in a form of CSV, download in a form of Excel sheets. Option is there even in a ThinkSpeak, right? You can see and you can import or export that data there. Now cloud computing comes in several different service models and deployment options for enterprises wishing to use it. The three main service models may be defined as the what are the service models which are there in a cloud according to NIST 2011 article. So which you can see here, software as a service. This is the first one. What is this software as a service? Refers to software that is provided to consumers on demand, typically via a thin client. The end users do not manage the cloud infrastructure in any way. This is handled by an application service provider, that is ASP, or independent software vendor, ISV. Examples include office and messaging software, email or CRM tools housed in the cloud. The end user has a limited ability to change anything behind the user specific application configuration settings. Now, the software as an I am using particularly, assume I am using an Outlook, and that Outlook is meant only for my company to share, to send a messages or emails from one user to the another user. Many banks is maintaining like that, all are private banks. Like that, I'm using a cloud, and in that particular cloud, I can use different tools, softwares, and charges will be there for that. Assume that, for example, we are some 100 workers are there, and 100 workers should send mails, check mails, and all. So, which are within that particular group, where routers cannot be connected to that. So that type of things and other tools also will be taken into the consideration. Now, platform as a service, now that is PaaS. So refers to cloud solutions that provide both a computing platform and a solution stack as a service via the internet. That is refers to cloud solutions that provide both a computing platform and a solution stack via internet. Where a computing platform can also be made, and a solution can also be generated there itself. At the moment, the customers themselves develop the necessary software using tools provided by the provider, who also provides the networks, the storage, and the other distribution services required. For example, I want to connect to my particular app. Whenever this particular threshold value is so and so and this value is so and so, the notification should be sent to the app automatically. So how these thing you will do, that is the platform as a service. In a cloud, you have to do, you are storing a data, that sensor data, whatever is there, you are storing in a cloud. In a cloud, what you will do, in turn you are going to connect to that particular app. So how you are connecting to that particular app, again with the APIs only. But when this is a particular value, means you are computing there itself at that platform, you need some space there. And then if this is so and so the condition, then only the notification should be sent. So that type of a service is also given. Next, infrastructure as a service. So in this model, the provider offers a virtual machines and other resources such as hypervisors to the customers. Pools of hypervisors support the virtual machines and allow users to scale resource usage up and down in accordance with their computational requirements. Just I'm having a monitor and a keyboard and all will be there. Just I'll connect to a net where I will work with that particular virtual machines. Means whatever I'm working and all, I will work with in a cloud machines only. So that can also be done. So that is another one important thing where we can use even the infrastructure service also. Coming to the next, the deployment models. This is another one very important. Direct question will be there for you. Explain in detail the services of a cloud and a deployment model. So service and the deployment models of a cloud. Direct question will be there. So coming to the deployment models, private cloud. The cloud infrastructure is provisioned for exclusive use by a single organization comprising the multiple consumers. It may be owned, managed, and operated by the organization, a third party, or some combination of them, and it may exist on or off premises. So private clouds will be there always. That is, it will be not meant for a public, and it will be meant for a single organization. For example, I have told you TVS company. TVS company will have its own cloud, means maintained by maybe a third party, that is an a Wipro or Google, whoever may be there, or means Amazon, like that. So they will be there and they will maintain the entire organization transactions and means solving all the problems of the consumers of that particular TVS sector, including authorized centers, dealers, and selling of the products, selling of the components for a vehicle, services giving to a vehicle. All these things will come under this particular thing. Like that, n number of companies are there. Those they will have their own private cloud. Then, community cloud. The cloud infrastructure is provisioned to exclusive use by a specific community of consumers from organizations that have shared the concerns. So here, this is one community, means one set of companies will come together and they will go with the cloud. Means they will make one particular cloud maintenance and all, and the cloud they will create. That is, example, mission, security requirements, policy, and compliance considerations. It may be owned, managed, and operated by one or more of the organizations in the community. A third party or some combination of them can be, it may be exist on or off premises. Yeah, even you can give to the third party, all we are in one community that we need the services, so and so services we need, and we'll make it as a community cloud. Not an issue. Then coming to next, public cloud. The cloud infrastructure is provided to open use by the general public like us. It may be owned, managed, and operated by businesses, academic, or government organizations, or some combination thereof, and it exists on a premises of the cloud provider. Generally, yeah. Even as an academicians, we need we can't spend more on anything like that. Now, even a ThinkSpeak will give you the public cloud. What do you mean by public cloud? Even ThinkSpeak for Firebase and AWS, yeah, Azure will also give, Microsoft Azure will also give a space. You can register, like you can, how in a ThinkSpeak you will create username and a password, same like that you can even create in Azure also, and even in a Firebase also. Myself, I am having a Firebase account, and I'm having some 2 3 entities also in that where we did some projects means databases like that. You can create your own database and you can access that to extract data from there and to means to put a data to that particular cloud. Everything is of a public cloud. Almost all some privileges will be very less here, but you can use the things, means almost all academicians, everyone will use that particular time. Then hybrid cloud. The cloud infrastructure is a composition of two or more distinct cloud infrastructures, private, community, or a public. So combinations they will take. For a public, assume that in a my cloud space, for a public I will give some space And for authorized dealers, it will be a different. The authorized dealers for a TVS, assume for a sake, I will tell you. In a TVS is having a cloud, right? Now in that, what should be a private and what should be a different things, community thing and all. For a public view also. Yeah, for a publics also, it should be viewed. I want to see what's the value of the components and what is the value of the vehicles of TVS company, and where actually the vehicles will be available, what will be the on-road price and all. If I want to check that, I need a information. So as it should be shown to me that information also. For example, authorized center persons will be there. Assume they will log in. Uh, if they will log in once, then automatically authorized services, whatever details, they are not capable to sell vehicles and directly or from without dealer things and all. They can't sell. Only service oriented authorized service centers will be there. So where components and service concentration will be more. Dealers again selling the bikes, means vehicles and all will be meant for them. That means the community of dealers will be different, community of authorized dealers will be different. Like this, it will be a different communities will be also be there. Now communities will be there, and some private things, cloud should be there. That means assume that a production, how many vehicles has been produced, and what is the cost for that produce of vehicles, how many vehicles has been dispatched to the warehouses, and from warehouses how many dealers they have taken how many vehicles, like this and all. Maybe it will be made within a private cloud. So all these things is needed for one company. Then definitely they will go for a hybrid cloud. So that is a one thing. Then purposes and considerations. What is the purposes and considerations you must have, regardless of whether you call it statistics, data mining, or machine learning? There exists a multitude of methods to extract different types of information from data. 100% from a cloud, whatever the way you will call it, either statistics you will call or data mining, machine learning, tell you whatever things you may need. How different types of data I can extract or information I can extract from that particular data, whatever stored in a cloud. The information can be used in everything from static reports to the interactive decision support systems, or even fully automated real-time systems. 100%. So whatever the stored information is there, from there I can take out a static printout reports, or I can make my actuators to run. Even in a war field and all, guns I can use to shoot the guns based on a decision support systems, where it's fully automated in a real time. That much importance will be there. Some examples of methods and purposes are as follows. We'll go with one by one there. Descriptive analytics. So what do you mean by this descriptive? Use of means, variance, maxima, minima, aggregates, and the frequencies optionally grouped by selected characteristics. So that is a descriptive analytics, where some statistical things you can apply on that. Then create a key performance indicators that enable a better understanding of the performance of complex systems such as cellular networks or on a oil pipelines. So there are example for descriptive analytics. Then predictive analytics. What is a predictive analytics? Descriptive analytics is a one. Already I am having a data, everything. So in that I will take a mean or variance. I will see in maxima, I will see hypothesis, I will find where estimation. These many users are already using this much bandwidth. Every evening, the bandwidth peak burst time will be more of a bandwidth like that for these calculations. For example, in a cricket also, strike rate, average batting rate, and average bowling rate, and average run rate, all those things you can do. That we'll call it as a descriptive analytics. What is a predictive analytics? Use current and historical facts to predict what will happen in next. That is, this is the thing. I will take a data of 3 months, last 3 months. This will be the data of that particular situation. If coming next 3 months, what will be the situation? Based on this particular data, we can predict that. So that is precision. That on that day we have seen activity precision agriculture. Forecast demand and supply in a power grid and train a model to predict how price affects electric usage to optimize the performance and minimize the peaks in the electricity consumption in a power grids. So that is the one example you can take. Predict maintenance on electromechanical equipment in a nuclear power plant. In a nuclear power plant, modeling a relationship between device health characteristics measured by sensors and historic failures. In the previous, what are the failures have occurred when the electromechanical nuclear power plants, and if this much of nuclear power is there, then what happens and all. So for that we need some data where we can predict, understand how electricity and water consumption relates to regional demographics. Yeah, if this is a area today, this many houses are there and this much of water consumption is there, assume in this area another in a span of 2 years 3 years these many houses may come up, and so what will be the water usage or electricity usage in this particular area? Then to supply that much of water and that much of electricity, what are the infrastructure ingredients is needed in a span of another 2 years? So how to enhance the water supply means assume that a small pipelines is there. Then if your houses are increasing in rapid another 2 3 years, so what to do the things? How to take the change? Model the effects of traffic lights on a city roads network based on data from cars and sensors in the city to minimize the congestion. So this is also another one very important thing. In almost all the developed countries, especially smart cities and all, the electric traffic lights will also change its timings. When how much red light should be there, how much green light should be there. Only in the morning and evening, automatically it will increase the time, and in meanwhile, in other timings, automatically it will decrease the timings based on the length of the traffic which has been there in the particular circle. You can make that also a good project, automated project. This is very important projects which will play a role in the coming next years. Even I will tell you, means this type of an experiments. What you will do first, what you have to do, the analysis should be done. This is very much important. That is, first what you have to do, you have to put a one camera, something there. Assume that Gaurish has did the project. See, in a surveillance camera, if any motion things are there. So for that, with the controversy to him, I will fix on a camera without motion. How much time the vehicles will stop there? So what is the length? I need a length calculation there. Assume that a road is there. If I calculate for this particular time of a red light, assume I will tell 120 seconds. And a 120 seconds, assume in this straight road, how much length of vehicles will be stopped. Are you getting my point? And every four roads of that particular circle, if I check, so I can manipulate that what time based on the length of the vehicles which has been stopped in that particular road. Based on that, a red light can be kept at until what time, green light can be kept until what time. So these are the things which will place in a very much important roles, especially when to make this increase automatic time and when to decrease. When simply assume that the light will be there for 150 seconds or 120 seconds, no vehicles will be there, especially in afternoon times and all. Simply vacant road will be there, the vehicles will be keep on waiting, then this is not good. So how to change this? These things, the predictions, these things is very much important in a projects what you are going to do. Next, clustering. This is another one very much important analysis which you can do. Clustering, identification of groups with similar characteristics. Perform the customer segmentation or find behavioral patterns in a large set of M2M devices. Mine time series data for recurring the patterns that can be used in predict analytics to detect, for example, fraud, machine failures, or traffic accidents. Anomaly detections, that is detect a fraud or smart meters by checking for anomalous electricity consumption compared to the similar customers or historic consumption for the subscriber. So this is also very much important. Means anomaly detections means somebody are using a power without any meters and all. So how much power is generated, distributed from one point, and how many meters are there? Total meter consumption is this much. Assume that some I'll tell like in a way like this: if some 200 watts of power has been sent, current has been sent, and only 150 watts of the power has been recorded in a meters, and they will put a bill has been generated. Then whatever are other 50 watts? So maybe like that, somewhere it's leaking. So where it is has been leaking. Like these type of things should be taken into the consideration. Coming to the next thing, that is M2M data fulfills all the characteristics of a big data, which is usually described by the four V's. What are that four V's? Volume. To be able to create a good analytical models, it's no longer enough to analyze the data once and then discard it. Creating a valid model often requires a longer period of historic data. This is very much how much data I need. 1 year back data, 2 years back data, 3 years back data, whether months data I need. It depends on a project. So what will be the volume of your data set? I means that should be decided. This means that the amount of historic data for M2M devices is expected to grow rapidly. Then velocity. Even though M2M devices usually report quite seldom, the sheer number of the devices means that the systems will have to handle a huge number of transactions per second. So what do you mean by this? What's the velocity? What is the speed of interaction of a device with a cloud? So how fast the interaction is there? You can observe in our regular projects and all, the sensor data will go and sit in a cloud. It will take some time, and again from cloud it is coming switch on and off from actuators. It will take some time. Why? Because they are providing a free. So in a free means heavy traffic will be there. Means no separate resource allocations will be there. A common resource allocations will be there, and all where velocity will be very less. So that will also be a problem there. So in a private clouds and all means space and all, that will be taken. And a variation. Yeah, given the multitude of devices types used in sorry M2M, it's apparent that the variation will be very high. This is further complicated by the use of different data formats as well as a different configuration of devices of the same type. So variation of different sensors or devices, actuators will be there, and even conversions will be there, where one device measures temperature in Celsius every minute, another device measures in a Fahrenheit. So it depends. So how to store in one particular way? There's a variation. Veracity will be there. It's imperative that we can trust the data that is analyzed. So either I can trust your data what you analyzed. That is very much important question, right? So what type of data you have analyzed? So this is called as a veracity. There are many pitfalls along the way, such as erroneous timestamps, non-ordinance to the standards, proprietary formats which missing semantics, wrongly calibrated sensors, as well as missing data. This requires rules that can handle these cases, as well as fault tolerant algorithms that, for example, can detect outliers. Even what a bulk of data is there, every data is filled. If some data are blank data are there, what to do? How to make this blank data to be taken into consideration? How I can leave? You see, for this and all, if you observe a data sets, lot of things you will get from that data set. Just type in a Google network based problems data sets. Like that, if you type and all different data sets will be there in a website. So where you can download or you can see many plenty of lines, lakhs together of lines data will be there. In that, at that particular time, the sensor has sent the right data. No, how much data I should consider is the correct data, how much data I should consider as a fault tolerance data. Either five, for example, either always 20% of my data will be in a fault data. How I should tell my 20% of data is a fault data? How I should tell? How to analyze like that? So this is the thing. That will call it as a veracity. So analytics architecture is a next M2M and IoT analytics. Now M2M and IoT analytics is the next topic. This much will be there for an cloud computing and exas, everything as an service. This much answer you have to write always, that you have to keep in your mind. Now coming to next this much only here up to the hybrid cloud. Now analytics will start at this particular stage, discussing with this particular analytics, continuing with veracity. Now we'll come to the architecture of the analytics. Now how actually the architecture of analytics will be there, observe this particular figure, why we should do the analytics, that will be taken into the consideration. Now M2M data sources is there here, enterprise data sources is there, external data sources is there. Assume I need some for my project, whatever I am doing, I have deployed some sensors and all. The sensors data also I am taking. Enterprise data sources is there, that is according to the enterprise working manual workings and all, what data is there that we have taken. And external data resources from outside also I need some data. So after taking this particular thing, now what are these things are there? Big data warehouse we are going to create. Out of these things we'll store here. Event stream processing, complex event processing data will be there. Based on an event I need a data. Traditional data warehouses will be there based on some traditionals, that is based on production, based on marketing, based on processing, based on packing. There's a traditional. So whole a big data warehouse one side will be there as a metadata frame. Event based also I can extract from these three things, and traditional data warehouses will be there. Now observe this, data access and query layers will be there here. So how a query layers you are going to put reporting. How a reporting you can do based on a queries. How I need so and so queries. For example, I'll tell you like this, where you can analyze the things. Assume I'm having a cloth shop, okay, and I'm putting in a shirts and pants. Just for a sake, I'll tell you. For me, the question arises always: either I have to take a large L pants shirts more, medium pant shirts more, XL pant shirts more, or small pant shirts more. How I can purchase. Assume, for example, I will tell you like this. I have purchased. What I have purchased is some 10 small shirts. I will take a shirts into the consideration. 10 small shirts I have purchased. Medium have purchased some 15, and L have purchased some 15. XL again I have purchased some 10. You can ask me the question, sir, why variation in these purchases? According to me, small purchasing of small shades somewhat selling of small shades somewhat it is rare. Why? Because always we should go with the 42 centimeters to 44 centimeters is a regular, that is M to L, almost all XL it will be there, not more than if XL. For example, XXL, it will be rare cases. How many shirts I should purchase on that? Now, for this, a question arises always. For this, what we have to do, we should do some analysis. Last time, assume that it's a very big, just a small shop, it's okay, 10 or 15, you can differentiate that. Assume that you're bringing a quantity in some thousands lakhs together. A big mall is there. So if there, if no one will purchase that S type of an shades, or it will be in a dump, or so what happens? The waste of stock will be there. Means we can't sell that. Dead capital will become. So because of that particular thing analysis, so how many I should order, how I should order, how I should put on an inventory for that. So this is a very, very much important calculations which you have to do. So that things, that analysis, I need a report. Just I'll ask, I need a report that continuously what type of size of a shirts will be sold in my shop from last 6 to 7 months. I assume that for 6 months I will take the moment of M and L type of shirts and t-shirts or more comparative to other. Then what I will do, if I want to order some 1 lakh of shirts, in that M and L will be more, and percentage. How many percentage of S has been sold from last 6 months? What may be the next? In different festival times, how it has been sold. So that the system should give automatic report to me. So how it will give automatic report to me means some background analytics somebody should do, or somebody should write a code. So that is advanced analytics and services. Somebody will expect even a services also. This is the overall architecture of the analytics. Now coming to the analytics architecture in depth, we'll discuss now. One of these is to serve as a platform of data exploration and modeling by the data scientists and other advanced information consumers performing business analytics and intelligence. As I told you, even scientists, they will use this type of data, and even consumers preferring the business analytics and intelligence many times. To do a modeling and all, data scientists may need this particular type of data. Has much time is spent on a data preparation before any analytics can take place. This is also an integral part of the architecture to facilitate. So when you see this, means the preparation, data preparation is very much important rather than analytics. Usually people will, what they will do, know, everyone will tell, I know machine learning very well. Why? Because I can apply any machine learning algorithms, that is KNN algorithm I can apply, and k-means algorithm, random forest algorithm I can apply. They will tell, and like this we can do the predictions and all. And we can do which is the nearest clustering and all I will do. Then I will ask one question. So then how will you use the input? They will tell the same thing like the petals of that. The petals thing is, that's a data set which is there already in the internet. They will take that data set and they will do. But what about the real time problems? This is very much important. What about the real time problems? Then the question will arise is, from a real time, how to take the data. So this is a question. You have to create your own website, wait until 6 months afterwards you do. No, that is also a means lot of time consumption will be there. Especially I'm the person, I think I thought you were Python, right? So Python is a one beautiful tool that even from websites, some websites they will allow to extract the data, especially some government websites, some other websites which you can search. So if you write some Python code, then you can automatically extract the data from that particular websites and you can store in a CSV format. Then that if you store in a CSV format, then automatically it will become a data sets. If you try, you can have that. That is there already exists. Python code even in Google also it's exists. Just you have to put like that, how to extract data from a websites uh, using Python. You need some JSON thing, means JSON connectivity to that particular website, and the JSON which you can use in your Python program. You can extract the data. So as much time is spent, so that is the thing. So before analytics, it should be there. Finally, efficient means of building and viewing reports as well as integrating with the backend systems and business processes is of importance. This requirements concern batch analytics, but should also be considered for a stream analytics. So this is also very much important. So once the data, everything is ready, So you have to build an efficient means of building views of reports. How to build a report? What report you need? Either graphical report of what analysis it has been done based on the goal, based on objective. You need a report, some business process and all. As I given an example of that size of an shirts. A sandbox for big data analytics can be realized in a number of ways, of which the Adobe ecosystem is probably the best norm. So, Adobe, you should learn this. You should learn this. Big data analytics should always done with this Adobe platforms. Other alternatives include, apart from that, columnar databases such as HP Vertica, Actina, Paracel, MPP, SAP, Sybase, IQ, and InfraBright. So these are all the columnar databases. Massively parallel processing architectures such as Pivotal, Greenplum, and Teradata Aster. So that in memory databases such as SAP HANA and Liquid will be used there. QLiquid. So these things are technology tools or latest tools with Adobe they are using in many companies. This is right. That's way. Meanwhile, when you find a time and all, at least you try to see what is Adobe and how to do the things with an Adobe. Even I can tell you that if you do a course also, anyway, good time for you now. If you do a course also, it's better on Adobe. That much importance is there. Then analytics architecture. Continuing with that, we'll continue in the next class. Almost all we are at the end stage of this particular chapter, methodology. Once we after discussing methodology, we'll go to the knowledge frames. So I think another 1 hour, 2 hours is enough to complete this third unit. Later on, we'll go for a fourth unit. Mhm. I'll stop here. Hmm. How was the class? Any doubts? ನಿದ್ದೆ ಎಲ್ಲ ಮಾಡಾಯ್ತಾ? ಆ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಹ್ಮ್ ಕೇಳಿಸ್ತಾ? ಎಷ್ಟು ಜನ ನಿದ್ದೆ ಮಾಡಿದ್ದು? ಸೂರ್ಯ
ಎಸ್ ಸರ್.
ನಿದ್ದೆ ಮಾಡ್ದೇನಾ?
ಇಲ್ಲ ಸರ್.
ಏಯ್ ಸುಳ್ಳು ಹೇಳ್ತೀನಾ?
ಇವತ್ತು ಬೇಗ ಆಯ್ತೆ ಸರ್ ನಾನು.
ಇವತ್ತು ಬೇಗ ಇದ್ದ ಅಲ್ಲ, ಇವಾಗ ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ
ಹ್ಞೂ ಸರ್ ಇದ್ದೆ.
ಇದ್ದ ಕೇಳಿಸ್ಕೊಂಡ ಕ್ಲಾಸ್? ಕೇಳಿಸ್ಕೊಂಡೇನೋ ಕ್ಲಾಸ್?
ಹಾಂ ಸರ್.
ಕ್ಲಾಸ್ ಚೆನ್ನಾಗಿ ಕೇಳಿಸ್ಕೊಂಡ?
ಚೆನ್ನಾಗಲ್ಲ, ಕೇಳಿಸ್ಕೊಂಡಿಲ್ಲ ಸರ್.
ಮತ್ತೆ ಯಾಕೆ? ಏನ್ ಮಾಡ್ತಿದ್ದೆ ಮಧ್ಯೆ ಮಧ್ಯೆ?
ಸರ್ ಅದು ಇಲ್ಲೇ ಆಚೆ ಬಂದಿದ್ದೆ ಗರಾಜ್ ಹತ್ರ.
ಅದೇ ಇದೆ ಇದೆ ಮತ್ತೆ. ಆದಿತ್ಯ, ಆನ್ಸರ್ ಯುವರ್ ಅಟೆಂಡೆನ್ಸ್. ಓದೋಗ್ಲಿ. ಆದಿತ್ಯ ಇಲ್ವಾ? ಆಬ್ಸೆಂಟಾ? ಅಜಯ್?
ಎಸ್ ಸರ್.
ಏನೋ ಇವಾಗ ಎದ್ದಂಗಿದ್ಯಾ?
ಇಲ್ಲ
ಅಮಿತ್?
ಎಸ್ ಸರ್.
ಅಂತಿಮ?
Present, sir.
ಅಪೂರ್ವ?
Present, sir.
ಅಶ್ವಿನಿ?
Yes, sir.
ಬಿಂದು?
Sir.
ದಿವ್ಯೇಶ್? What happened to him? Huh? Gaurish?
ಎಸ್ ಸರ್.
Gautami?
Present, sir.
Gudashekar?
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಹರಿಣಿ?
Present, sir.
ಇವಾಗ ಬಂದ ಹರಿಣಿ?
No, sir.
ಹೌದಾ? ಸೂರ್ಯ?
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ನೈನಾ?
Present, sir.
ನಜ್ಮಾ?
Present, sir.
ನಿಧಿ? ನಿಧಿ ಅಬ್ಸೆಂಟಾ? ನಿಧಿ? ಪ್ರದೀಪ್?
ಎಸ್ ಸರ್.
ಮಲಗಿದ್ದೇನಾ?
ಇಲ್ಲ ಸರ್.
ಪ್ರೀತಿ?
Present, sir.
ರಾಜೇಶ್? Rajesh? No, he is not still. Sahadev?
Present, sir.
I have sent number, Sahadev. Sorry, I am in native. I couldn't send a number. Now I have
It's
sent.
okay, sir.
I called him also. You can call him in evening.
Okay, sir. I will call.
Yeah. Saket. Saket. Socket. Santosh.
Present, sir.
Seema.
Yes, sir.
Sinchana.
Present, sir.
ಸಿಂಚನಾ
Yes, sir.
ಸಿಂಚನ ನಾನು ನಿನ್ನ ಡೇಟಾ ಕೇಳಿದ್ದೇನ್ ಗೊತ್ತಾ? ನಾನು ಕಳ್ಸಿರೋ ವೆಬ್ಸೈಟ್ಸ್ ಅಲ್ಲಿ ನೀನ್ ಇನ್ನೊಂದ್ಸಲಿ ನೋಡ್ಬಿಟ್ಟು ಡೇಟಾ ವಾಟ್ ಈಸ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಯುವರ್ ಪ್ರಾಜೆಕ್ಟ್ ಅಂಡ್ ದೇರ್ ಪ್ರಾಜೆಕ್ಟ್ ಅಂಡ್ ವಾಟ್ ಆರ್ ದ ಕಾಮನ್ ಥಿಂಗ್ಸ್ ಇನ್ ಯುವರ್ ಪ್ರಾಜೆಕ್ಟ್ ಅಂಡ್ ದೇರ್ ಪ್ರಾಜೆಕ್ಟ್ ಒಂದು ಟೇಬಲ್ ತರ ಮಾಡ್ಬಿಟ್ಟು ನಿಮ್ಮ
Okay,
ಪ್ರಾಜೆಕ್ಟ್
sir.
ಒಂದು ಕಡೆಗೆ ಬೇರೆ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಇನ್ನೊಂದ್ ಕಡೆಗೆ. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಹಂಗ್ ಮಾಡ್ಬೇಕಮ್ಮ.
Sir. Okay, sir.
ನೀನು ಅಶ್ವಿನಿ ಇಬ್ರು ಸೇರ್ಕೊಂಡು ಮಾಡಿ, ಪರವಾಗಿಲ್ಲ. ಹಂಗ್ ಮಾಡಿದ್ರೆ ಅವಾಗ ಏನ್ ಗೊತ್ತಾಗುತ್ತೆ ಅಂದ್ರೆ ಡಿಫ್ರೆನ್ಸಸ್ ಎಷ್ಟಿದೆ ನಮಗೂ ಅವ್ರಿಗೆ, ಆಮೇಲೆ ಕಾಮನ್ ಥಿಂಗ್ ಏನಿದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. ಅವಾಗ ನಾವೇನ್ ಚೇಂಜ್ ಮಾಡಬೇಕು ಈ ಸ್ವಲ್ಪ ಪ್ರಾಜೆಕ್ಟ್ ನ ಅಂತ ಗೊತ್ತಾದ್ರೆ ಪೇಟೆಂಟ್ಗೆ ಎಲ್ಲ ಯೂಸ್ ಆಗುತ್ತೆ. ಆ ವರ್ಕ್
Yes,
ನಾನ್
sir.
ಮಾಡ್ತೀನಿ, ನೀವು ಜಸ್ಟ್ ಇಷ್ಟು ಮಾಡಿದ್ರೆ ಸಾಕು, ನಾನು ಸೇರ್ಕೊಳ್ತೀನಿ ನಿಮ್ ಜೊತೆ.
Okay, sir. Okay, sir.
ಸರಿ. ಸ್ಫೂರ್ತಿ ಸ್ಫೂರ್ತಿ ಇಲ್ವಾ? ಸ್ಫೂರ್ತಿ. ಶಶಾಂಕ್.
Present, sir.
ವರ್ಷ.
Present, sir.
ಯಶಸ್ವಿನಿ.
Present, sir.
ಅಮೃತ.
Sir.
ಅನುಷಾ. ಅನುಷಾ ಇಲ್ವಾ? ಅನುಷಾ. ಅಪೂರ್ವ.
Present, sir.
ಸಾಯಿ ಸಿದ್ಧಾರ್ಥ್.
Yes, sir.
ಚೇತನಾ.
Present, sir.
ಕಾವ್ಯ.
Present, sir.
ಮಧುಶ್ರೀ.
Present, sir.
ಮನೇಶ್.
Present, sir.
ಸರ್ಫರಾಜ್. ಸರ್ಫರಾಜ್ ಅಭಿ
Present,
ತಾನ.
sir. Present, sir.
ಮುರುಗೇಶ.
Present, sir.
ಮಣಿ.
Present, sir.
ಪರೇಶ್.
Present, sir.
ಪೂಜಾ.
Present, sir.
Surprise, present, sir.
हाँ सरफराज कुछ बोल रहा था? What?
Yes, sir. I'm present, sir. Still.
What? Present I have put. Pratibha.
Present, sir.
Prashant Reddy. ಪ್ರಶಾಂತ್ ರೆಡ್ಡಿ ಇಲ್ವಾ? ಪ್ರತಿಭಾ. ಪ್ರತೀಕ್.
Present, sir.
ಆಯ್ತು. ಕ್ಲಾಸ್ ಅಟೆಂಡ್ ಆಗಕ್ಕೇನೋ ನಿನಗೆ?
ಹಾ ಸರ್ ಆಗ್ತಾ ಇದ್ದೀನಿ ಸರ್.
ಸಾಧನಾ.
Present, sir.
ಶಶಾಂಕ್. ಶ್ರದ್ಧಾ.
Present, sir.
ಶ್ರೀಧರ್.
Present, sir.
ತನೋಜ್. ತನೋಜ್ ಇಲ್ವಾ ಅವನು? ತೇಜಸ್ವಿನಿ. ಅಣಿ.
Present, sir.
ಆಶೀಶ್.
Present, sir.
ವಿದ್ಯಾ.
Present, sir.
ವಿಶಾಲ್. ವಿಶಾಲ್ ಇಲ್ವಾ? ವಿಶಾಲ್. ವಿಶಾಲ್.
Present, sir. Present, sir.
Okay, thank you very much. I'll stop recording first.